Hello everyone, and welcome to lesson 7 of our Scratch course. We're very glad to have you back and see you all well rested after your holidays. Last time we did a lot of things concerning sound and music and rhythm. We explored the sound palette in Scratch. We created some songs and rhythms using the Happy Birthday song as an example, and we also did a rather large program called a dance demo, which unfortunately didn't work out too well because it was quite complicated, having many elements, and we ran out of time during the lesson to get it done. The full demo is included on your flash drive, so you could load it up at home and have a look at it. And we have also done a from scratch video of lesson 6 with the full breakdown of that exercise. So if you want to go to our YouTube channel, which is linked to from our supplementary lesson page, which you can see the link for at the bottom of the slide, you can go and watch the whole video, and it will show you that dance demo from beginning to end. We'd just like to apologize again for it not working out so well in the last lesson. Okay, we also had some fun times during the holidays. We had our winter school, which was hosted at the Brain Boosters offices. We had 3 students attending. We had some nice snacks. We took a factory tour, scored some free headgear. In the top right hand corner of this slide you can see our learners standing next to boxes of preform plastic moldings. Those preforms come out of the blue and yellow injection molding machine to the left, and they then get heated up and put into blow molders and turned into plastic bottles. On the left here you can see the My Robot. That is one of the project prizes for the course, and we got to play with that a little bit and draw a few patterns on paper using the purple Koki that is attached to the robot, in much the same way that we have drawn various patterns on the screen using the Scratch programming language. And then the last picture in the middle of the slide shows a little Arduino microprocessor connected up to some electronic circuitry, which we used to emulate a traffic light. So we got the lights to change in sequence from green to yellow to red and then back to green. Then as an enhancement we loaded a sketch into Scratch which had different colored backgrounds, red, green and yellow, and then we moved the keyboard on the computer. We used the keyboard on the computer to move the mouse around on the background, and depending on which color the sprite was, it would light up the correct colored LED attached to the Arduino. We may have future schools or holiday camps, and we'll be sure to let you know if there are any if you want to attend. Okay, today's goals. We are going to do the following 3 things. We are going to explore messaging, broadcasting and receiving in Scratch. We're going to introduce you to procedures, and we're going to create our own blocks. Now, to give you a basic overview of broadcasting and receiving, on this slide in the bottom right hand corner there's a whole bunch of buildings, and those buildings are actually the multi-choice buildings in Randpark, just down the road from the Brightwater Commons, and that is where your DSTV signal comes from. You can see there are several satellite dishes on the roof of the building, a few big white circles and a few smaller grey ones. They beam the many TV channels of DSTV up to a satellite, and then that signal is bounced back down to Earth and picked up by the many satellite dishes attached to houses and apartments around the country, as you can see in the upper picture. Now Now the broadcasting and receiving of messages in Scratch works in much a similar way, and we will be covering that shortly. Okay, so our actual agenda for today is to use message broadcasting and receiving to draw some squares and to control multiple sprites. We will also discover how to create custom blocks and learn how to use custom blocks instead of messages. So how do sprites talk to each other? Okay, we've got a few blocks that'll help us do that. To send a message or broadcast, we use the broadcast or the broadcast and wait block, as you can see over here. To receive a message, we use the when I receive block. As you can see, the broadcast and wait blocks both have a dent and a bump on them, which means they can connect to blocks above and below them, whereas the when I receive block has a hat on top, and that means only other blocks can only connect to it underneath. You can't have any blocks sitting on top of it. So when you create your scripts, the when I receive block has to be at the top. Now we've seen blocks like this before, and they are generally the event type blocks. So we can see here when we're using our keyboard arrows to move our sprite around, we had a when arrow up, or when left arrow, or when down arrow, or when right arrow to control scripts. So we now have a new way to trigger code based on an event, and in this case the event will be a message. Now it is also possible not only for sprites to broadcast messages, but to receive messages that they themselves send. So in effect the sprites can talk to themselves. Now this might sound a bit strange, but it actually comes in quite useful, as we will see in our demonstrations later on. Now one thing to bear in mind with broadcasting and receiving, just like with your DSTV where you have multiple channels, you only can watch one channel at a time, and you will only see what's on that channel if you are tuned into that channel. So if you don't choose the right message in your when I receive block, then you won't get a message that might be intended for you, and we'll see how this comes into play in our demonstrations. Okay, so here is an example. It's not the full code, it's just enough code to give you an idea of how this all works together. So here we have a starfish sprite, and he's got a little megaphone, and he's broadcasting a jump message. Now just remember, whenever you see a block that's got a little triangle next to it, it means you can click on that triangle and it will give you a list of options, and we'll show you how that works a bit later. But for the meantime, our starfish is broadcasting a jump message. All the other sprites, the cat sprite, the frog sprite, and the bat sprite, can all listen for this message. So you can see here the cat sprite has got a when I receive jump block, and the frog sprite has got a when I receive jump block, but the bat sprite doesn't have one. The bat has only got a when I receive fly block. So the bat will in effect not hear any broadcasts made by the starfish which say jump. And you can also see over here with the cat has another receive block called when I receive walk. So if one of the other sprites broadcast a walk message, the cat would hear that message. Now it is also important to note that even though the cat and the frog both have a receive walk or receive jump message, the way they implement that message, or what I mean is the way they respond to that message, is different. So you can see the cat jumps up by 60, the frog jumps up by 40. The cat waits 1 second, the frog waits half a second, and then the cat jumps down by -60 and the frog by -50. So the cat is going to wait longer before coming down than the frog, but they are both responding to the jump message. Okay, so let's investigate how we create a message. So we have the broadcast block, which we can drag onto our script area. Then we click on the little triangle and it brings up this drop-down menu. The first option is message 1, which is the default option, but we can choose a new message. And if we click on that new message menu option, then it brings up a new message window and we can type a name in. And in this case we're going to type in jump. So now our broadcast block has a jump menu option, and our when I receive block also has a jump option in it. And this is basically how you create your different messages. Now bear in mind, a single sprite can send and receive multiple messages. Okay, so now we are going to draw a square with one sprite, and we have got two scripts here. We've got the stage script on the left hand side, and we've got the sprite script on the right hand side. If we have a look at what we've got here, we've got a when green flag clicked, and then clear, which will clear whatever has been drawn on the stage, and then we've got another event which says when stage is clicked, and when that is called we do a broadcast which says square. That broadcast from the stage is picked up by the sprite script because it has a when I receive square block, and when it receives the square block, it picks the pen up. Now this is important because the next step is that it's going to move to x and y, which is equal to the mouse x and mouse y. And if we don't pick our pen up, then we're going to draw lines all over the screen instead of just drawing squares. After we've moved, we set the pen color to a random color between 1 and 200. That just changes the color of the square every time we draw one. And then we put the pen down, and then we draw a standard block or standard square with a repeat function and a move and a turn. So let's see if we can replicate this in the Scratch editor quickly. Okay, so we go and click on our stage sprite, and we see that it has the when clicked and the clear, and when you click on the stage it then broadcasts the square. Then we go to our pen sprite, and we see it's got a when I receive square, pen up, move to mouse x and y, set a random color, put the pen down and draw the square. So if we run this script now, nothing happens until we click on the stage, and then you can see squares get drawn wherever I click, and a random color gets chosen every time, which may be the same or very similar to the previous one. So that is our basic broadcast from the stage, the square message, and received by the sprite, the square message. Okay. Alright, now we are going to move on to something more advanced. We are going to start drawing some flowers using a petal. You can see one of the petals in the upper right hand corner here. But we're going to have 5 different sprites, and each of them will have a different petal. So again, when we click on the stage, we're going to clear it, and then we're going to broadcast a draw and wait. Now previously when we drew our square, we didn't use the and wait, we just used the broadcast draw square. The and wait will mean that it will stop there, wait for everything to finish before it will continue. This is just to prevent you going bananas and clicking all over the stage while it's trying to draw the flowers and not actually getting a chance to finish. On the right here is the sprite script. Now like I mentioned, there are 5 sprites, so each of them will have a copy of this script in them. And the only difference will be the value over here for the x coordinate. And that will be different in each sprite so that they don't draw on top of one another. So let's go to our Scratch editor and load this sketch up, It's called flowers.sp2, and it should be found in your session 7 and 8 folder on your flash drive. So we go File, Open, don't save current project, go load flowers, and here you can see we have our 5 sprites with 5 different costumes. Costume 1, Costume 2, Costume 3, Costume 4, Costume 5. Each sprite has a different costume. And as you can see, the costumes look a bit weird. You wouldn't think that they'd make anything interesting, but once we add some stamps and rotation into it, then it starts to look more interesting. Let's go to our stage. Our stage has a very simple script. When you click on the stage, it clears and it broadcasts the draw message. If we go into our first sprite, when we click the green flag, it hides it, so we don't want to put anything on the stage initially, so you can see it's empty. When I receive the draw message, I set the color to a random color between 0 and 100, set the brightness effect to a random value between -20 and +20, I set the size to a random size between 80 and 100% of the original sprite, and then I go to an X value and a random Y value. You'll see, as I mentioned, this X value will be different for each sprite. So if I go there, we have -80, 0, 80, and 160. So you can see they don't overlap on the X-axis. The drawing here is just a repeat 12, repeat 12, repeat 10, repeat 12, repeat 20. So you can see some of the flowers have more petals than others, but all of them do a stamp and a turn, and the number of degrees times the repeat should always equal 360. So 12 times 30 is 360, 10 times 36 is 360. If we run our script now, it's running but nothing's happening. We have to click on the stage and then it will draw something. And as you can see, it looks different every time because we are changing the colors and the size and the brightness, even though we are using the same costumes on the same sprites. Alright, so what we are demonstrating here is we have a stage script which broadcasts a draw message, and then we have 5 sprites, each of which can pick up the draw message and then do something with it. The scripts aren't always the same. As we've seen, the number of petals vary and the X value can be different. Alright, now what's next? Structured programming. Structured programming is a way of putting scripts together which makes it easier to work with them. What we do is we break a large program down into small steps. Now you might be familiar with this concept if you've ever tried to bake a cake. You don't just take all the ingredients, throw them in a bowl, and then throw the bowl in the oven. You take certain ingredients, you mix those together, for instance perhaps some egg and sugar, and then when those are mixed together you maybe mix in some flour, and then you maybe mix in a few other ingredients. Some of the ingredients you might even mix separately and then combine together at a later time. Once you've mixed all the ingredients together correctly, you will transfer what you have into a pan and then put that pan in an oven. Now all these different steps are basically procedures which need to be followed in particular sequence in order to achieve your end goal, in this case being the baking of a cake. We do a very similar thing when it comes to programming. We try to make smaller code scripts because they are easier to read, because they don't have that many lines in them. They're easier to debug. Debugging is the activity of removing errors from your scripts, and they are easier to reuse. So instead of writing a square script every time you need to draw squares, you can create a square procedure which you can then reuse every time you want to draw a square. Now, just out of interest, you can see on the right hand side of the slide there's a picture of a logbook with a yellow piece of sticky tape, and under that sticky tape is a moth. Now that moth was found stuck in a relay in a Harvard Mark II, which was a computer which was built around 1946, and that bug was causing the relay to malfunction and hence the program in the computer to malfunction. So the operators at that time found the moth, removed it, and referred to the procedure of fixing their program as debugging, because they had to remove a bug. And that concept has stuck with computer programming ever since. So even today, if there are problems in the programs, when the people, being the programmers, go in and fix them, they refer to that as debugging. Now, even though we are breaking down our programs into smaller pieces called procedures, it is very important to call those procedures in the right order. Because if we go back to our cake example, if you had to take your eggs and not break them and add some flour and then put it in a bowl, put it in the oven, then take it out and try and mix in some sugar and butter, that wouldn't work very well. So it's very important to call your procedures in the right sequence. So let's look at an example of how we can structure a program. In the picture you can see here quite a long program which does a number of things. It basically initializes a sequence to do some drawing with a pen, and then it draws a square, a triangle, and another square. So you can see the first two blue lines and the first four green lines together can be combined into a procedure which is called initialize. Below that we have a standard block which draws a square. So we can create that as a DrawSquare procedure. Then we have a similar procedure which draws a triangle, which we can create as a DrawTriangle procedure. Then we have a simple block which rotates by 180 degrees, which is a one-line block, so there's no point in creating a procedure for that, so we just copy it in place, and then we draw a square again. Now you can see we've got two draw squares there, so instead of writing the code out twice, we just call the same draw square procedure twice. So that saves us time because we get to reuse code, and it makes debugging easier because we only have to debug the draw square code once. Okay, so now we are going to try and do the same drawing of flowers, except we are going to use one sprite instead of 5 sprites. And the difference is that we are going to have one sprite which has 5 different costumes. So if you have a look at the code here, you can see on the sprite script we have a switch costume to leaf 1, and then in each loop we have a next costume function which will move to the next costume, being the next petal in the sprite. We have also made a change here where from the stage we've sent out a broadcast of draw, which gets picked up by the sprite, and then the sprite itself does a broadcast of draw flower. Now, as we mentioned earlier, sprites can talk to themselves. They can broadcast a message which they can pick up themselves and act upon. So let's go ahead and load flowers2.sp2 from our sessions 7 and 8 folder. Okay, so we have flowers sp2 loaded. Again, on the stage we have the same script. When the stage is clicked, we clear and we broadcast a draw and wait. Now we only have one sprite, and if we have a look at the costumes, we can see that this sprite has 5 costumes. So instead of having 5 sprites, each with one costume, we now have one sprite with 5 costumes. If we look at the code here, when this green flag is clicked, we hide the sprite again because we don't want to show anything initially. When the sprite receives the draw function or draw message, it sets the position to -160, switches the costume to leaf 1, and then it repeats 5 times. The reason it repeats 5 times is because there are 5 costumes. It picks a random Y value between -100 and 100, and then it broadcasts the draw flowers and wait. Draw flowers is a message which we receive in the same sprite. We then, as before, set the color, brightness and size to random values, and we repeat, in this case always 15 times, so each flower will have 15 petals. And when this is completed, we come out of this, we change our X by 80, so from -160 we'll go to -80, then to 0, then to +80, and then to +160, which as before moves the flowers along so that they aren't drawn on top of one another. Then we get the next costume being the next petal, and we repeat the loop. So if we execute this, click on the green flag, nothing happens as before because the stage is waiting for me to click with the mouse. And as you can see, it draws flowers as it did before, but now we are using one sprite instead of 5. That one sprite has 5 costumes, and it uses message broadcasting to talk to itself. Okay, so now we've done message broadcasting and receiving, which is certainly very useful. The next thing we're going to do is look at making custom blocks. Now here's a little illustration which shows how custom blocks make life easier. In lesson 2 we learned about motion and drawing, and this was how we initially drew a square. We'd move 50 steps, turn 90 degrees, move 50 steps, turn 90 degrees, and basically do this 4 times. In lesson 3 we learnt about the repeat block. That value there shouldn't be 10, it should be 4. And we were able to collapse this down into a repeat block which repeated these 2 steps 4 times. Now we are going to learn how to make custom blocks where this DrawSquare will replace this and in effect this. So let's see how that's done. Okay, we are going to use the More Blocks palette, which we haven't looked at yet. So you click on that and then it'll bring up 3 buttons: make a block, add an extension, or load experimental extension. For our purposes we're only going to look at the make block button, which if you click on it will open this new block window. It'll have a little purple icon there which you can then type the name of your procedure in. In our case we're going to type in the DrawSquare procedure and then click on the OK button. Doing that will do 2 things. It'll add a DrawSquare block to your More Blocks palette, and it will also add a define DrawSquare block to your scripts area. So if we go and have a look at this now, we're going to use this to draw a square. So let's try and do this. So we're going to go File, New, don't save, Events, when clicked, Pen, Clear, to clear the stage. Okay, then we're going to go when space key pressed. We're going to put our pen up because we don't want it drawing lines all over the stage. Then we are going to go to XY, where the mouse is currently. So mouse X in X, mouse Y in Y, and then we're going to draw a square. But first we have to define our square. So we go draw square, click OK. There's our draw square, and we put that over there. Now we have to define what our square does. So we want to put the pen down, and then we want our repeat block, repeat of 4, because that's how many lines the square has, and then we are going to move 50 and rotate 90. And now we should be good to go. If we click now, or press the space button, wherever the mouse is, it's going to draw a square. And there you go. You've used your first procedure, or custom block. Alright, now we are going to take our drawing of a flower and change things up a little bit. We are going to replace the message broadcasting and receiving with procedures. So let's go back and load up our session flower2.sp2 and replace our draw flower with a define draw flower and our broadcast with a draw flower. So let's go back to sp2, and we are going to make a block called draw flower, and that we are going to put in here. And we're going to take that away, and we're going to connect it up like that and take that away. Now the only broadcasting is from the stage broadcast draw to the flower when I receive draw, but now the flower is going to call the procedure draw flower, which is defined here. And if we run our script as before, there's nothing on the stage. I have to click, and as before it draws flowers which look different almost every time. Right. So as you can see, technical difficulties, and we are back. Sorry for this, folks. Really didn't expect PowerPoint to crash on me. Anyway, we are back. So our first step was to create a draw flower custom block. We then replaced the when I receive draw flower with the draw flower definition block, and we replaced the broadcast draw flower and wait with the draw flower block. So this is the script that we landed up with. This is also available as flowers3.sp2 in your session 7 and 8 folder. Okay, so one more thing. If you want to edit your custom block, you can right click on it in the palette. This will open up the edit block window, and then you can click on the options arrow here, which will give you these additional options. Don't worry about the first 4, we will be exploring those further in the next lesson. But if we want to make our drawing faster, we can check the run without screen refresh and then click OK. So if we go to our sprite and we click edit, click on the arrow next to options and run without screen refresh, click OK, and we stop our sprite, our script, run it again, and now you can see the flowers draw almost instantly. We don't see them drawing them one petal at a time. Now the reason this works is when we are doing procedures like this, they have built-in weights at the end of each time they run, and those weights cause you to be able to see the drawing procedure. by choosing the run without screen refresh, it doesn't put those weights in and it runs almost immediately. Okay, so that concludes the lesson. You have one homework problem, which is problem 2 from your session 7 and 8 folder on your flash drive. Please check out lesson 6 on our website, and we will also have lesson 7 up from Sunday, hopefully. Okay, next lesson we're going to be investigating how we pass parameters to custom blocks, which is very useful. We're also going to use nesting of custom blocks, and we're going to break programs down into procedures in a more formal way. As a last step for this lesson, we are going to show you how to do a chat program like we did before in one of our earlier lessons, where we used wait commands to synchronize the chatting between two sprites. But in this case, we are going to use messages and custom blocks to do that. So let's go file open, and we're going to load our hi bear, hi cat. Okay, as you can see, we've got two sprites here. We've got our cat and we've got our bear. There's nothing on the stage, there's no scripts on the stage. So we have to start things off, and we're going to start with the cat, and we have this when green flag clicked, say hi bear. This is an initialization routine. Once this is done, the cat and the bear will carry on chatting to each other until you stop the program. The hi bear custom block is defined over here, and it says hi bear for 2 seconds and then broadcasts a hi bear message. When the bear receives the hi bear message, it calls the hi cat custom block, which is defined here, and it calls next costume. Now this bear has two costumes, one with the arm down, one with the arm up. So if we leave it with the arm down, it'll put the arm up, say hi for the cat, put the arm down, and then broadcast hi cat. When we get back to our cat, it has a when I receive hi cat message, and it calls the hi bear, and this will basically go into a loop until you stop the program. So if you run this, hi bear for 2 seconds, hi cat, puts arm down, hi bear, hi cat, and it will carry on running. And as you can see, it's a very simple program which uses both concepts we explored today, being the message broadcasting and receiving, as well as the creation and use of custom blocks. Okay, that is it. Thank you for watching, and we hope to see you at the next lesson.